that negative is not under the square root. That is like saying -1 times the principal square root of 112. And the largest perfect square that will go into 112 is 16. It goes in 7 times. So apply the product rule. Take the square root of the 16. As for the 7, because I picked the largest perfect square factor of 112, there's nothing left to get out of the 7. It's prime. The only perfect square factor that goes into that is 1, and that doesn't help us simplify anything. So we get -1 square time -4 times the square root of 7. We could do the prime factorization. 2 is the smallest prime that'll go into 112. It goes in 56 times. 2 goes into that 28 times. Into 28 14 times. And into 14 7 times. 7 is a prime. So negative square root of 112, we could also write that as the -1 times 2 to the 4th times 7. And as we saw in the last example, if we apply the product rule, that 2 to the 4th, when we take its square root, that's really the same as raising it to the 1/2 power. So multiplying those exponents, we have negative. It's not part of the square root. It's not part of what's being raised to the 1/2 power. So that negative is still out there. -1 times 2 squared times square root of 7, i.e. -4 square root of 7. That's the exact answer we'd be looking for. If we check, let's ignore the multiplying by the -1 here when we check on the calculator. Here is a decimal approximation of square root of 112. Close the parentheses. Versus a decimal approximation of 4 times the square root of 7. Close the parentheses. Again, you may see in some of these comparisons in the last digit or two a difference, but that overall it looks the same. Here we're seeing exactly the same thing.